Hello, chemistry students. I wanted to give you a little bit of background just because I'm not really sure what you've had and what you haven't had as far as conversion factors. So I wanted to just kind of, I guess, introduce that to make sure that you've done some of this using of conversion factors, because this whole chapter that we're in is actually all about how to use conversion factors in converting from grams to moles and so on. And I know I demonstrated the first part of this already, going from like finding what a mole is. And then when I was going to jump into the next part, I'm like, I wasn't really sure if you've had any background with that. My students in college chemistry would have covered conversion factors at the beginning of the year. So I'm just going to do a quick, what is a conversion factor and how do we use them? So, if we have things that are equalities, like 12 inches is equal to 1 foot, we can use that as a conversion factor. Sorry, I'm writing with my mouse, so it's really messy. 12 inches is equal to 1 foot, so I can write it this way. Or I could put 1 foot on the top. 1 foot is equal to 12 inches. I can put this whichever way I need to use it in my equation. And I'll talk in a little bit how we know which way that might be. We can do the same thing with a dozen, right? 1 dozen equals 12 of anything. So I could say one dozen is equal to 12. And let's just pretend I'm talking about eggs. Because when we do a problem, we would be given some sort of tangible thing to write, to use that with. Or I could say that, 12 is equal to 1 dozen eggs, right? So I can use that either way. Whoops, got a little crazy there. And then, even though miles and hours are not equal, if I'm talking about speed in terms of miles per hour, I would use that also as a conversion factor. So 60 miles is how far I went in 1 hour. Or I could say in 1 hour, at 60 miles per hour, I traveled 60 miles, right? So how would I use that in a problem? And again, I'm just going to do an example and then we're going to jump into molar conversion. So let me just make one up here really quickly. Okay, so here's my quick little plan or quick little lesson on how I would set this up. So I always start with what might be important information. Okay, and I underline that. I'm traveling 400 miles. So the question is how many hours? So I know what I want to find out is how many hours. So I'm going 400 miles. How many hours is that going to take? And I like to think, oops, I actually need one more piece of information. Let's say I'm traveling All right, I needed this little piece of information too. So I'm traveling at a rate of 55 miles per hour. That is also an important piece of information. I couldn't solve this without that, right? I need to know how fast I'm driving. So I'm going 55 miles an hour. I'm going to go 400 miles. I want to know how many hours it's going to take. So I know, here's what I usually do. What I want to end up with is my answer is going to be in hours because I want to know how many hours it's going to take me to get there. My rate of speed, I know that that's a conversion factor. And then the only piece of data I'm given is I'm going 400 miles. So I'm going 400 miles. I want to know how many hours that's going to take. So I'm starting with 400 miles. And again, I hope this is review for you. This is just a quick lesson on how to use conversion factors. So here's the big rule. Whatever I want to keep goes on top. Whatever I want to go away is going to go on the bottom. So I want to get rid of miles. So when I'm looking at this conversion factor, I'm starting with miles, and I actually want miles to go away. So miles has to go on the bottom. Okay. Also remember, when I have a whole number, it's really like a fraction over 1, right? It's like this, 400 over 1. And the only reason that's important is because units that are across from each other will cancel out. So I know you probably covered this. I know they cover this in math class, but in case it's been a while or I don't know, for some reason you missed that. So now miles is going to cancel out, and I'm left with hours. That's my quick skinny overview of how to use that dimensional analysis. So now to solve this, I'm going to take 400, which by the way is on the top, 400 times 1, so 400, right? And then I'm going to divide it by 55, that's on the bottom. So I'm going to grab a calculator. So what you can do to help you kind of keep this organized is I can do this first. I can write this fraction and then I can solve it. Like I don't want to leave it this way. This doesn't really give me 400 divided by 55 hours is not the answer I'm looking for. I actually have to do that calculation. It's going to take me 7.27 hours. So hopefully that helps kind of review a little bit on that dimensional analysis piece. Okay, and so here is how we use conversion factors to convert from the mass in grams of something to the moles. And remember last week we talked about what moles were, right? So they're this magical thing where if you have the molar mass in grams of a substance, if we look at the periodic table, we said, just as a quick review, please, the videos are posted, so if you ever feel like you need to look back, anyway, so that you have that option or opportunity to do that. But anyway, so I looked at my super cool interactive periodic table, and basically, so the molar mass is the atomic mass, but in grams. So if I look at sodium, we can see the atomic number is 11, but the atomic mass is 22.99. I would round that to 23, so 23 atomic mass units. But if I have 23 grams, then I have 1 mole. And also remember from last week, we said that 1 mole is equal to this really big number called Avogadro's number, this 6.02 times 10 to the 23rd. So for today, we're just going to go through some molar conversions. So I'm just going to do some examples with you. All right. So let's solve the problem. How many moles of H2O are in 125 grams of H2O? I'm going to start by underlining what's important. It's probably important to know that I have H2O because remember the last time we talked I said you can find that molar mass of a substance and that we actually need that in that conversion. And then I want to know how many moles, so I want to end up with moles. I think I'm going to just circle that. And then I want to know how many moles are in 125 grams. All right, so starting with, the only number I'm given is this 125 grams, and I want to get that to moles. I have this little cheater chart. This is actually right from your book. You have this in your book, and it tells you if I'm going from mass in grams to moles, I'm going to follow this arrow. I actually need to find the molar mass, which is grams per mole. So I do need to look up this molar mass. I'm going to look on the periodic table, and I'm going to say hydrogen. Hydrogen has a molar mass of 1, like 1.0097, whatever, but we're just going to round to 1. But I have 2. I have 2 hydrogens, so that's going to be, I have to double that, right? Oxygen has an atomic mass of, it's 15.9994. We are just going to round that to 16. All right, and then I add that up. My molar mass is 18 grams per mole. That's what molar mass is. So this is my 18 grams per mole. So I'm going to start with and I know I want to end up with moles. And I'm going to use this conversion factor right here. But I want to use my conversion factor so that grams will cancel out, and I want to end up with moles. Since I want to end up with moles, I know moles needs to be on top. Boom. And then I can do this. Just to remind you that the 125 is a whole number, so it's like a fraction over 1. So I'm going to take 125 divided by 18 in my handy dandy calculator. 6.94. I'm just going to go 6.9. And there's 6.9 moles of H2O in 125 grams. And then always analyze, does that make sense? Well, if there's 18 grams in 1 mole, this is like way more than 1 mole because it's way more than 18. It seems like it's about 18 times 7. If it was 18 times 10, it would be 180 grams. That's just the way I kind of go through it in my own mind. So the second part of this really is converting from moles to particles. And I think I'm going to do a separate video for that. But you can see moles is kind of in the center of everything. So there are these really important units that allow us to go from quantity in grams actually all the way to particles. But again, we'll save that for another video.